Hello guys, SQL Server databases contain many different types of objects, including tables, stored procedures, and views. Most implementation of SQL Server database include these types of objects, so it is important to understand how to use them and the benefit that they provide. In this module, we need quickly to review the following: create table and use data types, and constraints to ensure integrity, create and use views. And finally, we need to create and use the stored procedure functions and triggers. For now, we just try to understand these objects, and later in the main lab, we need to implement all of them. We start with tables, and in tables, usually you will have data types, where you have numeric data type, character string data types, and other data types like date. You might have some or all of them, depending on how many columns do you have. And in addition to the data types you have in the table, you will have keys and constraints, identity property, and schema. We start with data type. If you take a look to this creation, we have a create table, line items. As you see here, we have now different attributes: order ID of type integer, not null, product ID, then we have unit price, and finally we have quantity. Then we now need to build a primary key, and the primary key is going to be a combination with this definition of order ID and the product ID, combination of both of them as a primary key under the definition of constraint, which is pk line items. And with such definition, as we see here, we have three different type of data. We have integer value in the definition of order ID. With unit price, we have money data, and finally with the quantity, we will have a small integer data. In addition to these three, we still have a long list of numeric data like integer, small integer, big integer, tiny integer. And also for the numeric, we have real and float. So you can add a fraction to the number. Then we have character string data types. You have two major types, non-Unicode and Unicode. With non-Unicode, usually you can use the English language. With Unicode, you can use other languages in addition to the English. So you can define these types like char, varchar, and varchar max, which is going to allocate all the space for the definition of such type. Or you define like this item can hold 10 characters, 20 characters, depend on which scenario do you have in your network or in your database design. Other data types like date and time, binary, etc. Then we have keys and constraints. We already learned how to deal with primary keys in previous modules. Constraints are database objects that you can create to restrict the type of data that a column can contain. With constraints, we have unique, default, and check constraints. With the unique constraints, we need to ensure uniqueness for non-primary key columns. With the default constraints, provide default value, and finally with check constraints, check values against defined criteria. Then the next object is identity property, and we can use it when we create a table to automatically add a value to a column for each row. The identity property generates incremental value beginning with a user-defined seed value and increasing by a user-defined incremental value. Identity by itself does not ensure uniqueness. We need to use a primary key or unique constraints for such object to make sure we have a unique value in each cell. The limitation with the use of identity property is that you can have only one column per table being defined with identity property. Now moving to other objects, we have a schema. Schema namespace that represent a logical container for tables. Schema is also a security boundary. Configuring permission at the schema level reduce administrative efforts and improve security. We will see also how to implement the identity property and the schema in the lab. After that, we have views, and the view simply is a stored select statement. We can create a view transact SQL statement, can be used to create views as we see here in this example. We create a view, the name of the view as we have select, so we pick customer ID, name, date of birth, order ID, order date from person, customer as C table, and we join that with sales.order as O table, and the condition is when C customer ID equal O customer ID go. So by this now we can retrieve back the data. It's similar to the query, but this time the query we are going to use it as a create view. That create view can be saved and be displayed when we need. Now you might ask, why do we need to have this stored view? Why we don't just simply create a query? The idea is you don't want end user to use queries by themselves. You need to provide them only the views or the queries they can use to retrieve data. So when you implement a list of these views, then you can assign users who they got permission on a specific list of views, while maybe the other VIP end users, they can access to the full list. And by this, they can display only what they need to have. So the main reason behind the views is for security, not a technical reason. Because when it comes to technical, you can simply, as an admin or developer, to use any query to display the data you want. Finally, we have stored procedures, triggers, and functions. The idea of a stored procedure is to encapsulate transact SQL statement, such as insert, update, delete, and select statement in one block, and use the create procedure transact SQL statement to create a stored procedure. This is how you can create it, so then later you can just call it. And system stored procedures enables the management of database object and task. You might ask now, what is the benefit of it instead of a direct query? And the benefit is, as you see, we can have a better modularization, performance, and security. You can assign who will be allowed to access to which procedure and start to use it. And the performance, because some procedures, they might have a bulk of scripts, so it will be easier to call procedure rather than try to run this bulk time after time. And with modularization, because you know exactly what kind of procedures are in there and how they can be used. And that also is going to help you with the standardization and code reuse for the junior developers, because you are going to restrict the kind of bulk or script they might have to use. As we know, usually when you create a procedure or a function, you might be able to send data from the main code to the code in the procedure or in the function. So you can define input parameter, which enable users to pass values to a stored procedure when they execute it. Parameters have a data type, so here to define it, you just need to add this @ That @ is going to work as a bridge between the main code and the code which is inside your procedure, so you can process the data being received through the main code inside the procedure itself. Another SQL Server database object called triggers. Trigger is an encapsulated transact SQL statement that execute or respond to an action performed in a database. You cannot execute trigger by calling it in transact SQL statement as you can with the stored procedure. Only the triggering action causes a trigger to run. There are three types of triggers that SQL Server support: data manipulation language, which is DML triggers, data definition language, DDL triggers, and logon triggers. DML is a subset of transact SQL that includes insert, update, and delete statement. So the DML trigger runs a response to insert, update, or delete actions on a specific table. DML has two types, after triggers and instead of triggers. With after triggers, this one allows the triggering action to complete before running. Let us have an example. You might create a trigger that updates a table in an inventory database in response to the orders that customers place in an order processing database. So when a customer orders a particular product, the trigger automatically updates the stock level for that product in the inventory database. However, if the initial order entry fails to complete for any reason, the trigger would not run and the inventory database would not be updated. With the second one, instead of triggers, the triggering transact SQL statement never runs. The code in the trigger runs in its place. Key advantage of instead of triggers is that they provide a way to run updates against views that reference more than one table. Other type, which is DDL triggers, which is a subset of a transact SQL that include create, alter, and drop statement, as well as the grant, deny, or revoke statement used to configure permissions. DDL triggers run in response to DL statement that execute in the database. An example, you might create DDL trigger to prevent the use of alter statement to change a table. And the last type, which is logon triggers, this one is going to run a response to the logon sessions at the level of the SQL Server instance. These kind of triggers are usually used to audit logon activity. We can use create a trigger transact SQL statement to create triggers, and we will see how we will do that again in the lab. Now finally we have functions, and function is a database object that perform a specific task, such as find the total values in a column or extracting part of a character string. Functions are reusable, and each time you call the function and you provide a different argument to that function, you will get a different result. But the process inside the function is the same. We have two major types of functions, built-in and user-defined. With built-in, we have also another two. Scalar functions operate on a single value and return a single scalar result. And the other one, which is aggregate functions. With this one, we operate a range of values and return a single result. So I might provide an array and you find the total summation of that array and retrieve it back as a single result. With user-defined function types, we have inline table. With this one, return a table populated by a single select statement. And this one, we don't need to configure the structure of the table that the function returns, while in the multi-statement table valued function, we have to declare now the structure of the table the function return. In the next module, we'll start with our main project. We are going to see how we can create everything and how to use, in addition to the creation of database, table, schema, primary key, foreign key, we will see how we can create also functions, procedures, and how to use them. So by the end of the lab, you will see all what we had so far learned in theory to be explained in there with examples. So for now, we just need to understand what about these objects, not how to use them. In a practical side, we will learn exactly how to implement and use them. Thanks for watching.